Okay, so let's try these for your response ones. So these all have to do with speed, velocity, all of those. All right, so a particle moves along the x-axis, so its velocity at time t is given by v of t equals negative quantity of t plus 1 times sine of t squared over 2. At time t equals 0, the particle is already at position 1. Okay, so that's kind of like what we just did in the homework. All right, so A says find the acceleration of the particle at time 2. Is the speed of the particle increasing at t equals 2? Why or why not? Okay, so the acceleration, how is that related to velocity? So we're going to have v prime of t. Okay, so v prime of t, you can actually take the derivative of this. But since we were asked at 2 anyway, what else could you do? Do you guys remember how to find the derivative and plug in a number all on your calculator? You can do something called inderiv. Yeah. So you're going to go to math, and it's 8. And you're going to plug in that function. So negative x minus, or x plus 1, I guess, times sine of x squared over 2. And then your x value, so do comma, x, comma, 2. And that gives you a value. So what I'm going to write, oh, not x, t equals 2. So this kind of shows that I've now set it up and I'm just using my calculator. When I write that, it's saying find the velocity at time t, plug in t equals 2. Okay, you could also write it as v prime of 2. Same thing. I'm going to write this as a of 2. Okay, so when you do that, you get 1.587 5. So you could say 1.587 or 1.588. Okay, let's say we didn't do it with our calculator, though. So let's say this was a non-calculator portion, which it wouldn't be because t equals 2 would be weird. But let's say it's a non-calculator. We don't know how to do the inderiv. So if we don't, then we go ahead and we take the derivative, so v prime of t, and you break it into 2 pieces. So I'm going to take this whole piece here and this whole piece here, and use your product rule. So I'm going to have negative t plus 1, so that normal, times the derivative of the sine part. So I'm going to have cosine t squared over 2 times t, right? The derivative of t squared over 2, plus the derivative of negative, the quantity of t plus 1 is just negative 1. Oh, negative 1. It'd be 2t over 2. And then sine of t squared over 2. Now, sometimes that inderiv function will give you like errors. It will give you, if there's a lot that it has to compute, the calculator, it will mess it up. So it's always good if you have extra time to go back and check these. But let's say we plug in 2, we'd have v prime of 2. So I'd have negative 3 cosine of 2 squared over 2, so 2, times 2, minus 1 sine of 4 over 2, so 2. So I have negative 6 cosine of 2 minus sine of 2. And it'd probably be okay to actually leave your answer like that. Yep, it's the same thing. Okay, now it says, I almost skipped it, it says, is the speed of the particle increasing at t equals 2? Why or why not? Okay, this is a very, very hard question. Okay, they are starting to put more and more of these questions on the AP test. So this was from 2003. I could definitely see this on the 2012 one. Okay, so is the speed increasing at t equals 2? What do you guys think? Yes, why do you think yes? Okay, good guess. So you're accelerating and it's positive. Okay, what you actually need to do is, since it's talking about the speed, in order for the speed to increase, you need for both the velocity and the acceleration to be positive or both the velocity and the acceleration to be negative. That would mean that the speed increases. Does that kind of make intuitive sense? Okay, let's say your velocity is negative, so you're going backwards. But your acceleration is positive. What does that mean?
You're accelerating.
Yeah, if your acceleration's positive, that means for every second you're adding on like a meter per second. So you could still be going backwards, but you're going slower. You're slowing down. It's because you're already at a negative velocity, and if you have positive acceleration, you're slowing down. Do you guys see what I'm saying? Okay, if you I don't know if you do or not. Okay, if let's say you're going forward, so if your velocity is positive, okay, what if your acceleration is negative? What's happening? You're slowing down. That one's the obvious one for you guys to think of. That's like if you're going up a hill, right? You're still going up the hill. Your velocity is still positive, but you're getting slower and slower and slower. Okay, so your speed would not be increasing. The speed would be going down. Does that make sense? The speed? Because your velocity is, or the speed is the absolute value of the velocity. So it doesn't matter the sign of the velocity. Is your number getting bigger or smaller? The absolute value of the velocity is getting smaller. You were going like 50 miles per hour, and then all of a sudden you're going 45 miles per hour, and then you're going 42 miles per hour. Your speed is decreasing. Okay, so that's what you need to remember. This is a very good thing to put on a note card. So you could write that out. If velocity and acceleration are both positive, or if velocity and acceleration are both negative, the speed is increasing. Obviously, if you have positive and negative in any order, the speed is decreasing. Now, what I always like to think of is the actual graph, which is hard. So let's say I have velocity. So I'm graphing velocity for my y and time. How do I represent acceleration? What's acceleration? How's it related? It's a slope. So in this case, my velocity is negative. My acceleration is a positive slope. So think about these values. If I'm talking about the speed, let's say this was at negative 50, this was negative 40, negative 30. Your speed is 50. Your speed is 40. Your speed is 30. Your speed is decreasing. Does that make sense? So you can think of the graph if you need to. All right, enough about that. So we need to explain what's happening. So we need to show that both the acceleration and the velocity at 2 have the same sign. So we need to find v of 2. So v of 2 is negative 2 plus 1 sine of 2 squared over 2. So it's negative 3 sine of 2, which is negative 2.728. So is the speed increasing or decreasing? Yeah, so it's decreasing. So you'd say the speed is decreasing because, I don't know why I just spelled it that way. So because velocity, so v of 2, and a of 2 have different signs. Okay, part B. So find all times t in the open interval 0 to 3 where the particle changes direction. Justify your answer. So how am I going to find if something changes direction? Yeah, you're going to find when it changes from positive velocity to negative or from negative to positive. So let's go ahead and graph the v of t. So let's graph this in for our y1. So I'm going to have negative x plus 1 in parentheses sine of x squared over 2. And it says your interval is from 0 to 3, so I go ahead and I change my window from 0 to 3, just so I know I'm only in that interval. I'm not going to find anything extra. Okay, it looks like maybe only one place. Maybe at 0 it might be as well, though. what's sine of, so sine of 0 is 0, right? So at 0, it was already at 0. So my graph looks like this. But at 0, it's not changing direction, right? It's just starting out in the negative direction. Okay, so it's only right here. Okay, so that would be at t equals, we find the 0. So second trace 0. Get on the left bound, get on the right side, and then guess. I got 2.507, so 2.5066. And just in case, if we need this number later, let's store it. So let's go second quit, so it goes back to our normal screen, and hit X. Notice how that number comes up. So hit stow, and store as a letter. So like store as A. So just in case, we have that stored as A. So if you want to write it so you remember. Because sometimes you'll need that number again. Okay, so your answer for this one is at t equals 2.507. It doesn't say seconds or minutes or anything, so we can leave it like that. The particle changes direction. And you can justify by saying because the velocity changes from negative to positive, or you could even just say because the velocity changes sign. All right, C, find the total distance. So the total distance traveled by the particle from 0 to 3. Okay, you can do this a couple different ways. You could reflect your graph over, so you use the negative, from 0 to 2.507, so that would be convenient if you've saved that number. And then from 2.507 to 3, it was positive anyway, so you can do that. Or the easiest thing to do, which you guys learned yesterday, is to just use the absolute value button, right? So you're going to compute the absolute value of v of t dt from 0 to 3, because distance is positive. Okay, luckily we already have that in for y1, so we're going to do math 9. Absolute value, so hit math, go over to number, absolute value. y1, so you're going to hit variables, so vars, y vars, function y1, comma x 0, comma 3. Okay, you should get 4.334 or 4.333, either way. Okay, I did leave something out though, I'm realizing. Okay, anybody have any ideas? This isn't actually the correct answer. What did I leave out? It's what? No? Where did I originally start? You started at 1. So what you're really doing is you need to think of, if you had from 0 to 3 of some kind of function, this would be f of 3 minus f of 0, right? So if you wanted to find f of 3, your position at 3, the total distance until time 3, you add on f of 0 to the other side. Okay, so let's say something like, but original position is 1. Okay, so what we're doing, so we're finding from 0 to 3 for your time. I think I'm saying this wrong. What do I need to do here? Pause. Confusing. Okay, so you don't need the original position as one, actually. I'm lying. Okay, because that is just finding the total amount that you've traveled from 0 to 3, that total distance. If I asked how far away you were from the original, then you need to subtract it out. Does that make sense? Like if I asked how much you moved, you need to figure that out. Okay, D, so during the time interval 0 to 3, what is the greatest distance between the particle and the origin? Show the work that leads to your answer. So what do you guys think for the greatest distance? So looking at your graph of velocity, so this was the graph of velocity, right? You were negative, and then all of a sudden your velocity went positive. Okay, so you're moving backwards until 2.507. Does that make sense? Okay, so what's that telling you? So you're moving further away from the point, and then all of a sudden at 2.507, you're getting closer to that point again, right? You turned around. So we need to check some different values. So we need to check, and sometimes they'll do like tables, the position at different times. So at 0, you're at 1. You're at position 1. Okay, then all of a sudden you have a negative amount that you're adding to that 1. You're walking backwards away from 1 until 2.507. Okay, so this is where we need that, the original position. So we're going to find the displacement from 0 to 2.507. So luckily you kind of already have that set up, so get rid of the absolute values from the last one. So do second enter. And that's why we've stored that A. So we have it stored as A. So that's negative 3.265. So you went backwards that amount, negative 3.265, but you were already at 1. That's where that 1's coming into play. So where are we now? Yeah, negative 2.365. You're thinking of it like you were originally at 1, you've now moved back this certain amount during that time, so you're now here. So you're now at negative 2.265. Oh, that's a 2, 2.265. Okay. And then you also want to see what happens at the end. So what happens at 3? So it doesn't look to me like you're adding on that much distance to make up for how much you went backwards, but you really should check it. So now you could do from 2.507 to 3 to find the displacement there. So go from A to 3. Okay, and that's adding on to where you last were. Do you guys see what I'm doing? It's like 2 steps forward, 2 steps back. So we went backwards. Now we're going forwards, 1.068. So take negative 2.265 and add on 1.068. So you're at like negative 1.97. So what's the greatest distance? Distance is positive. So the greatest distance is 2.265. And that would be enough work to show your answer, right? So you've shown the setup. A lot of times they'll say something like candidates, and you get a point for showing the different candidates. These are the different candidates for the time where that greatest distance occurred. So they like to see that table in these situations. Okay, so scoring. So for part A, you got 1 point for having A of 2 correct. So 1 point for that. You got 1 point for knowing that the speed was decreasing and having the reason for it. So 1 point for that. You got 1 point for t equals the square root of 2 pi. So let's see what the square root of 2 pi is. So square root of 2 pi is 2.506. So we had that. 2.5066. All right, and then 1 point for the justification. Whoops. So because the v of t changes signs. So you now could have gotten 4 out of the 9 points on those, just those parts. Then C and D were a little bit harder. So 1 point for having the correct limits. So 0 to 3. Those are called limits of integration. 1 point for having the correct integrand. So the part next to the integral sign. So the absolute value of v of t. 1 point for the answer. So 1 point for 4.334. Part D, 1 point for knowing that your distance could be positive or negative. And then 1 point for the answer. So 1 point for that, 1 point for knowing that we could have plus or minus. Okay, does this make sense? Okay, let's try another one. Okay, let's go to the squirrel one. Classic AP question right here. Okay, so a squirrel starts at building A at time 0 and travels along a straight wire connected to building B. So this one's kind of nice because you're actually starting at position 0, like building A. So between 0 and 18 units, I guess, seconds, whatever it is, the squirrel's velocity is modeled by the piecewise linear function defined by the graph above. Okay, so we have that little graph. So at what times in the interval 0 to 18, if any, does the squirrel change directions? Give a reason for your answers. So you guys should definitely know this one. So when does the squirrel change directions? 9 and 15. That's because this is the graph of the velocity. So the velocity goes from positive to negative, and then it goes from negative to positive in those places. So A at t equals 9 and t equals 15 because v of t changes sign. And that's the only justification you need. B, at what time in the interval 0 to 18 is the squirrel farthest from the building A? How far from building A is the squirrel at this time? So I could do this by just looking at it. I could tell how far it was from building A. I mean, not the exact number, but I could tell. Where do you guys think that it's furthest from building A? At 9. Why do you say that, Rachel? Yep. If you're adding up this area, is that what you're saying? This velocity? So the area that you're worried about. Because when you're talking about distance, you're talking about integrating the velocity, right? So see how this area is really big, this trapezoid? But then this trapezoid isn't enough to cancel out how much you are from the building. Do you see what I'm saying? Like, this is a huge area, so this is a big distance, and then you went back a little bit. And then it's positive again for even more. So it's like, oh, maybe you went even more than this blue one, but it doesn't look like it. I mean, it looks like it's much smaller. But you really should do the candidates test thing that I was talking about. So you should do this little table, and you should say these different locations that you might want to check. So at 0, you're at position 0. You're already at building A. Okay, at 9. So you're traveling forward, and then all of a sudden at 9, you're going to go backwards. So you're going to go back towards building A. So the squirrel was going away and then back. All right, so at 9, you want to find the distance it is from building A. So you find the area of this trapezoid. So it's 1/2. H is, can't read mine, blind. 20, is it 20? That's the height, so 20. B1 plus B2, so 9 plus, between 2 and 7, there's 5 units. So 10 times 14, so 140 is its position. Do you guys see how I got that? Okay, now all of a sudden it's going back towards building B, so now we're adding in a negative number. So that's this trapezoid, this blue trapezoid. So that's 1/2. Its height is 10. B1 is so between 9 and 15, it looks like, so 6. B2 is between 10 and 14, so 4. So 50, and it's negative. So the squirrel has gone forward a certain amount of distance, and now it's going back 50. So you're at 90. So that's at time 15. All right, and then the last one is at 18 that you need to find. So 18, now the squirrel's going forward again. So this little trapezoid is 1/2. Your height is 10, it looks like. B1 is 2 and 15, 3. So 2 plus 3. So 25. So you're going to add on 25. So 1/15. Okay, do you guys see how I got this?
Wait, what are you adding to?
The last number. Yeah, so you're just doing one chunk at a time. So you're saying at 15, I was 90 meters away from the building. So now what if I add on this positive distance? Okay, then I'm going to be 115 away. Okay. So when is it the furthest from building A? That's at 9 seconds, or whatever it is. I don't know how fast this is going, 9 minutes. So it'd be a pretty speedy squirrel to do it in 9 seconds. I bet it could, though. Depends on the units as well, right? If it's meters, feet, what is it? Yeah, centimeters, yeah. All right, so at time t equals 9, the squirrel is 140 units from building A. All right, C. So find the total distance that the squirrel travels during the time 0 to 18. So distance is always positive. So you're taking all of those positive numbers that we found. So this first trapezoid was what, 140, is that what we said? The second trapezoid was 50. The third trapezoid was 25. And you're going to pretend that they're all positive. And you're going to add them together. Because the squirrel is traveling forward a certain distance, and then backwards a certain distance, and then forward a certain distance again. So you're adding those positive distances together. So you're going to have 140 plus 25 plus 50. Yeah, I'm blanking. 215. Thanks. All right, so 215. All right, and then D. So write expressions for the squirrel's acceleration, velocity, and distance from building A that are valid between 7 and 10. Okay. This one's a little weird. So when you're looking between 7 and 10 units, you're along this line right here, the green line. Okay. So its velocity is a constant. It's constantly decreasing, right? That's by a certain amount. Okay. So we need to find some different things. So if I had the velocity, then I can find the acceleration by finding its slope, right? Its derivative. Okay, do we know the slope? So you can find the slope, yeah. So it's -10. So your acceleration is the slope between these 2 points right here. So the first point was 7, 20, and the second point was 10, -10. So you just find the slope between those 2 points. So 20 minus -10 over 7 minus 10. So you get you get 30 over -3. So you get -10. Okay, that's your acceleration. So if I have the acceleration, how do I find the velocity? Negative 10t plus c. You integrate it, right? Are you following? So you'd integrate the acceleration. So you get negative 10t plus some constant. Okay. We need to know what the velocity was at time. Let me think how we should do this. It's not time 0 because, I mean, it's not talking about this number over here. It's talking about if this green line were extended, where would its y-intercept be? That's what it's saying. So if my line were extended, how could I find its y-intercept? So any ideas on how to find that? You could plug in a point, right? So you're going to have v of t equals negative 10t plus c, and we want to use one of those points that's on the end, so like 720 or 10, negative 10. So let's use 7 for t, 20 for v of t. So you get c equals 90. So that means v of t is negative 10t plus 90. Okay, so we found our acceleration is negative 10. Our velocity is negative 10t plus 90, so we're integrating and getting that. We now want to find the distance. So what do you think now? Yeah, you can integrate that. All right, so your position, I guess I should, distance from building A. Is distance always positive? Distance is always positive there anyway, so it's the same as the position function on that little green line that I drew originally. So position, s of t, would be integrating, so you get negative 5t squared plus 90t plus d, some new constant. That's a plus. All right, and then we need to find that one. Okay, this one's a little bit harder. So let's see, we don't know its position during that time. What do we do? Okay, if I did, let's say I wanted to find, like if I did v of t dt from 7 to 10, let's say I did that. That would be your position at 10 minus your position at 7. Let's see if that helps us. Do we know either of those? No. Let me pause and think. Okay, so it goes back to our little chart that we did up here. So we did position at time 0, position at time 9, position at 15 and 18. I want position at time 7 in particular. And what I'm going to do is I'm going to make this t here. So we'll call this v of x dx. It doesn't really matter. So that would end up being s of whatever t is minus s of 7. Does it make sense? Because you're integrating velocity, you're getting position. Yeah.
Why do you have 2 Could you use any point that's on the line?
You could use 7 or 10, yeah.
But you can't use any line.
Yeah, you could actually, maybe you could use 9.
It's on the line.
Yeah, you could do that. You could use 9. So let's say we use 9. So if I use 9 from 9 to t, since that's on that line, we know 9 is let's see, s of 9 is 140. So we have s of t minus 140, v of x dx. So s of t could be written as the integral from 9 to t v of x dx. plus 140. So that would be one way to write it. Okay, but we still need to integrate that. So when we integrate, we'd have, gosh darn it. Let's go back to here where we were. So when we integrate, if we're integrating velocity, we get negative 5t squared plus 90t plus some d, which isn't going to matter anyway because it's going to cancel out when we plug in our numbers. Okay. I wrote down the answer. So your answer should be negative 5t squared plus 90t minus 256. So you'd plug in t, which we already have anyway. These should be x's, I guess. So plug in t and then plug in 9, and you should get this in the end.